Welcome to our probability class. We'll firstly look at what are called combinations and permutations. Now, combinations and permutations are concepts in mathematics that are used to count and calculate numbers of possible selections or arrangements. So we have what we call permutations, and permutations are simply arrangements of elements that are fashioned in a certain specific order. So the order of the element in this case matters. So when you're dealing with permutations, we're dealing with a number of possibilities that is typically denoted by n permutation r, npr. Or in some cases, we just put p, n, comma, r. So this formula is given as follows. So where n is the total number of items in a set, r is the items taken at a time. Sometimes we call this the radical. Then this exclamation mark is simply what we call a factorial function. So a factorial function is used when we are multiplying numbers backwards. So, for instance, if you're asked to find the factorial of 5, it is simply multiplying 5 times 4 times 3 times 2 times 3 times 2 times 1. So the factorial of 5 will be, this is 6 by 20, this is 120. Factorial of 4 is simply 4 times 3 times 2 times 1, which is simply 24. So this is our factorial. Now, if we're given a permutation, for instance, 5 permutation 3, according to our formula, NPR simply means you find the factorial of the number of items you're picking over the difference between the number of items. So NPR will simply be 5 permutation 3. So we're going to have 5 on top, and the difference, 5 minus 3. So at the bottom, we're going to have the difference, which is 2. And on top, we're going to have the 5. So we're going to now use the laws of maths. 5 times what? 4 times what? 3 times what? 2 and 1. Then below here, we have 2 times 1. You just cancel these ones out. And what we're going to get is 60. So our n permutation r is 60. N permutation r is 60. So this computation can also be done on the calculator. I don't know whether you have a calculator with you there. Some of you have a Casio calculator, others have a Sharp. Kindly identify your calculator. I'll start with the common calculator, which is a Casio calculator. So you can also do it the calculator way directly by punching the following. So if you're asked to find the permutation of 5 permutation 3, how do we do it on a calculator? So a calculator will look like this. So in this case, just to magnify it, are you able to see? So we have 5 permutation 3. So you can punch where there's 5 here, and you press permutation. Permutation is hidden, so you have to press shift and NCR, then permutation 3, then equals. You're going to get your answer. What answer are you getting? Right, permutation 3. What answer are you getting? Ideally, you need to get the same answer, which is 60. All right. So let's try another permutation. By the way, the factorial of 0 is 1. The calculator can also calculate the factorials independently for you. So factorial, for instance, you have 5 factorial, or let's say 4 factorial. So you need to punch 4, then shift, then this pattern here that is below the shift, then equals. You're going to get your factorial, which is 24. 5 factorial, and you punch it there. What are you getting? What is 5 factorial?
Colin, just repeat yourself. You said you press 4, shift.
4 shift and the button below it here. If you're using a Casio calculator,
Okay.
then equals.
Okay.
You found 24.
Okay. Yes.
Then 5 factorial, what are you getting?
120.
120, correct. How about 0 factorial?
1.
1, right? So in most cases, people fail to understand how 0 factorial is 1. However it is, I don't know, but you need to know that 0 factorial is not 0, it's actually 1. Are there any people with a sharp calculator here? Well, I also don't leave them out. Okay, so for the sake of the recording, I'll explain either way. So a sharp calculator looks like this. So our n factorial is on the number 4. So if you're going to calculate 5 factorial, you simply have to press 5 and shift, then here, that's where your n factorial is, then equals. You're going to get 120. But to find the permutation 5, permutation 3, you can get it directly here by pressing 5, shift, the permutation is here. It's actually on the 6. So you're going to press 5, shift, 6, 3 equals, and you get your value there. Now, when we're dealing with permutations, we are looking at different ways in which we can arrange elements. Now, this happens to be one of the toughest topics. For instance, you have letters 1, A, B, C, and D. So you're asked, we have letters A, B, C, and D. In how many ways can we put them in pairs? So remember, the number of letters here is what? 4. And the items you're selecting at the time, we call those the radicals. Pair means 2. So how do we find the permutation 4, permutation 2? Who remembers using the calculation, what do we do? 4 factorial over the difference, 4 minus 2. So on top, we're going to have what? The 4 factorial. Below it, we're going to have what? The 2 factorial. Then you multiply. 4 times 3 times 2 times 1. And below it, we have 2 times 1. These decimal points I'm putting here are just signifying that what? We're multiplying, so don't get confused. So my 4 permutation 2 will ultimately give me a 12. But what is the application of this 12? It tells me that if I'm going to rearrange these words in pairs, I'm going to have them in 12 ways. For instance, I'm going to have AB, AC, and AD. Then I'll swap them. It's the same as this one is a different entry. BA, CA, DA. And I go now. BC, BD. And I swap them here. This is what? CB. And this is what? DB. Now I start with a C now. CD and BC. I mean, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are different ways in which I can rearrange these ones, 12 ways. So in fact, this is what RATSA uses when they are coming up with number plates. They're trying to identify the different ways in which a number plate can be rearranged. So we can have a question, for instance, say at a birthday party, we have 10 people and the cameraman wants to get people, but can only capture 3 at a time. So meaning the radical is 3. So 10 permutation 3, you calculate it on the calculator directly, or if you want, you can do it manually. On a calculator, those who have a calculator, what is 10 permutation 3?
Is it 720?
720. So this now takes us back to the definition, what we were trying to understand when you're dealing with permutations. What are we looking at? We're looking at different arrangements that can be formed by understanding our pattern. It is very particular with the order. AB is different from BC. AB is different from BA. So permutations look at arrangements of elements in a specific order. But when do we know that this is a permutation and this is a combination? Now, a combination, on the other hand, looks at content rather than order. If we're dealing with people, for instance, in how many ways can a committee of 5 be made from a certain number of people? So John and Mary, it's just the same as Mary and John. So you cannot say that John and Mary are a different combination. So combinations by definition looks at a selection from a set without considering the order. In combinations, the order doesn't matter, but the number of possible possibilities denoted by C combination R, or denoted as follows. Now, this is very important for you to understand, because when we're dealing with binomial distribution, you need to inevitably know how to calculate this. So this one is given by n combination R. So here it is slightly different, n factorial, then the difference n minus R factorial, and we multiply the radical again. So if we are doing 5 combination 3, so this 5 factorial, number 1, and the difference 5 minus 3 factorial, then times the radical, the 3 factorial. So here we're going to have what? 5 factorial over 2 factorial times what? 3 factorial. And then you break this down. What is 5 factorial? 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. So these ones are the same, they'll cancel. 2 times 1 is 2. So 2 into 4 is 2. So the combination 5 combination 3 will ultimately give us a 10. Are there any questions so far? Are there any questions so far? All right, so let's try 7 combination 3. Can somebody help me? How do we expand this? 7 combination 3? So it's a 7 factorial on top, then the difference 7 minus 3 factorial, then times the radical on 3 factorial. So here we're going to have 7, and here we're going to have what? 4. Here we're going to have 3. What do we have there? 7 times 6 times 5 times 4 times 3 times 2 times 1. Then here, you start with a bigger number, so that it's easy for you to cancel. 4 times 3 times 2 times 1. Then here, 3 times 2 times 1. This cancels with that. This cancels with that. So you're going to have 7 times 5, which is 35. So that is where our combination will be. 7 combination 3 will give us 35. So I'll teach you a Pascal's triangle, which is very easy to follow if you don't want to do the calculations, but it's very important that you understand that. So you start with 3 ones, 1, 1, 1, you add 1 plus 1, 2. Then you go in this column, 1 plus 2, 3, 3 plus 2, 3, and you close. Then you now keep adding, the answer you put it in between, 1 plus 3, 4, 6, 4, and you close. And here, 5, 10, 10, 5, you close. And here 1 plus 5, 6, 6 plus 5, 15, 10 plus 10, 20, this plus that, 15. And here we have what? 6. Then you close with ones. Here you add, what do we have here? 7. Here we have 21. Here we have 35. Here we have another 35. Please, I hope you're not getting confused. Here you're just adding this is 21. 6 plus 1 is 7. Then you close. Now, this is only applicable when you're dealing with combinations. So n number combination 0 is 1. So 7 combination 0 is 1. 7 combination 1 is 7. 7 combination 2 is 21. 7 combination 3 is 35. So you just count the number. So if I'm going to ask you to give me the combination of 7 combination 4, you go where there's 7 as the second number after 1. So you count 0, 1, 2, 3, 4. So 7 combination 4 is 35. From the Pascal's triangle, can somebody give me 6 combination 3? What is 6 combination 3?
20.
0, 1, 2, 3.
20.
So it is 20. Okay, what is 6 combination 6? A number combination itself is 1. So 6 combination 6 is what? 1. 7 combination 7 is 1. A number combination 0 is itself. 7 combination 0 is 1. 6 combination 0 is 1. A number combination 1 is itself. So 7 combination 1 is 7. 6 combination 1 is 6. 5 combination 1 is 5. A number combination second last is itself. So 5 combination 4 is 5. 6 combination 5 is 6. 7 combination 6 is 7. So I don't want you to be abusing the calculator at certain points, because certain things you can just do them at your fingertips. All right. So I ask, what is 4 combination 2? From the table, what is 4 combination 2?
6.
6, yes, 0, 1, 1, 2, 6. Now, I don't need you to worry so much, because the calculator can do everything for you. So all you need is to know how to punch it. So I hope you all have your calculator nearby. I need you to check on your calculator. You know, the majority would have a Casio. So Casio is the easiest calculator that we can use. So there's now a modern Casio. Don't get the complicated calculators, because later on I'll be teaching you how to do regression on those calculators. They're very, very handy, more than you think. They work. So the modern calculator for the Casio looks like this, but this one is not very complicated. It's Blair. So if you're going to do numbers that are more than that are big, like 12 combination 3. You punch 12, combination is somewhere. Where's the combination now? Let's see. So we use the one we use at first, the calculator. So it's very important that you know your calculator and you see the way we use the calculator is the same the way you use your remote control. Just make sure that you follow the guidelines properly. So let me go back to the traditional calculator, which okay. So I hope you are all able to see the calculator. So if you're looking for 12 combination 3, press 12, 1, 2. The combination is here direct. There's no need for shift. Then 3 equals. What are you finding? 12 combination 3. What is 12 combination 3? Anyone? Press 12 combination 3 and equals. What are you getting?
220.
230. Then to find the permutation, if I ask
It's 220, not 230.
to what?
220.
20. Okay, thank you. How about if you're asked to find the permutation, 12 permutation 3, you punch 12, then shift this button, a P will come, then 3 equals. What are you getting?
1,320.
Okay, 1,320. All right, so you see a permutation is different from a combination. Now, how will a question come when you're dealing with a combination? So you'll be told, for instance, that a kitchen party is yet to be formed from a family of 12. And in how many ways can we make 3 subcommittees? The radical is 3. Our n is what? 12. So we're going to use a combination here because we're not interested in the arrangement or the order. We're interested in the content. So this is 12 combination 3, which will give us what? 220. Okay. 12 combination 3, which will give us 220. Now, let me take you to the revision kit I shared with you. This pamphlet, we're going to look at question number 1 under permutations and combinations. So let's apply everything that we've just discussed now. Okay. So we are told in this question to say from 8 accountants and 5 actuaries, so doing actuarial science, how many ways can we select 3 accountants and 3 actuaries? How many ways can we select 5 people subject to the condition that each committee will have at least 2 of each, 2 actuaries and 2 accountants? So what data are we given in here to start with? The numbers. So for accountants, how many do we have? We have 8. Okay, actuaries, we have how many? 5. So in how many ways can we find how many? 3 from the 8 accountants and 2 from the 5 actuaries. So we're going to say 8 combination 3 and 5 combination 2. In statistics, the word and is usually used in terms of multiplication. So what is 8 combination 3? 56. What is 5 combination 2? Is 10. So to multiply this, we're going to find 560 ways in which we can get that combination. So this is not a probability, it is an order or arrangement. Part A. Part B, in how many ways can we have 5 subject to the following conditions? You have at least 2 in each. At least means a minimum of 2, but the total must be 5. We can get the same combination we had because this gives us the total people we're getting. Here were 3, here there were 2. We can say 8 combination 3 and 5 combination 2. That's the first way in which we can do it. Or we can get 2 from this one here. From the 8, we get 2 accountants. And from the 5 actuaries, we get what? 3 actuaries. Is it possible to get 1? Then we get 4, we balance up from the other one? No, because the condition is that it should be at least 2. So this is the only combination we could have. So the word or, I explained this during lunchtime to say stands for what? Addition. So here we're going to have 56 times 10 plus 8 combination 2. On the calculator, what are you getting? 28. 5 combination 3. On the calculator, what are you getting? It's 10 as well. We're going to get 560 plus 28. The total is the total number of ways in which, so this is 840 ways in which we would have those different ways. For this course, you need to practice a lot. It's not a once-off. We need to try as many questions as possible to understand the gist of everything. So permutations and combinations help us understand our binomial distribution and Poisson distribution. Now, let me take you to probability. Unless any questions from what I've explained so far. All right. So probability has axioms or properties. So these properties will help us understand how to do the computations. So probability of an event A is simply given by the number of A events over the total number of what? Events in the sample space. Probability of A given B is a pattern using Bayes' theorem. We bring down the B down there, and on top we intersect A intersection what? B. Similarly, if it was the opposite, if we had B given A, using Bayes' theorem, our A will come down there, then we will intersect the two letters A intersection B. So this is called Bayes' theorem. The probability of a complement of A is simply subtracting 1 minus the probability of A itself. So it means that the opposite, if A is 20%, the opposite of A is 80%. Then we also have the union set formula. A union B to unite is to add. So if you have a scenario like that one, you simply add the probability of A plus the probability of B minus the intersection of the two. I'm going to teach you some basic probability using what are called contingency tables. So in a scenario where you're given A, B, X, and Y, 2, 4, 6, 8, for instance, the first thing you need to do is to get the totals. The column totals and the row totals. Here we have a 6, here we have a 14, and we go here we have a 8, here we have a 12, the total is what? 20. So what is the probability of getting an A? Remember, I said A is simply the number of events that we have that pertain to A over the total sample space. And that sample space is the grand total in this case, which is 20. So the total for A is what? 6. Divided by the grand total, which is 20. What do we get? 0.3. Can somebody try? What is the probability of B? Probability of B?
Is it 8 over 20?
Good. The total for A, for B is 8. Then the sample space total is what? 20. So what do we get? 8 over 20? 0.4. Correct. Who wants to try the probability of X?
Could it be 12 over 20?
Correct. 12 over 20. Which is 0. What? 0.6. How about the probability of Y?
14 over 20.
14 over 20. Which is 0. What? 7. All right. Now, probability of A intersection B. You go where they meet A and B. They meet at 2. When you draw a plus, they meet at 2. So 2 over the sample space, which is 20. It will give you 0.1. Help me find the intersection of X and Y. Where do they meet? X and Y, where do they meet?
They meet at
8.
8.
8, good, over 20, which will give us 0.4. Now, who remembers the formula for the union set of A union B?
The probability of A plus the probability of B minus the intersection.
Probability of A, good, plus the probability of B minus the intersection. So what is the probability of A? What's the probability of B? And what is the intersection? A was 0.3. B was what? 0.4. And the intersection, 0.1. The total is 0.6. Okay, the ladies this time, Help me find the union set of A and B.
Probability of X plus probability of Y minus probability of X intersection Y.
Excellent. Now give me the figures. X is what?
0.6.
Y
0.6, 0.7,
intersection
0.4.
2.4. And what is the final answer? Point 9.
0.9.
Right. So far, I'm happy with you. Quick, can you remember the word or is synonymous to what? Union or what sign? Addition.
Addition.
The word and is synonymous to what?
Intersection.
Multiplication.
Yes, intersection or what? Multiplication. So we are remaining with just three things. A given B. A given B, I'll give you a shortcut. You go where they meet A and B, they meet at 2, but the total for B, the total is what? 8. So 2 over 8 gets 1 over 4, 0.25. Still, if you want, you can use Bayes' theorem. A given B, using Bayes' theorem is what? A intersection B over the probability of what? Of B. So what is A intersection B? We found 0.1 over the probability of B, we found 0.4. So 0.1 into 0.4, we still get 0.25, the same thing. But maturers don't want to think a lot. So I just teach you where they meet A and B, they meet at 2. But the total for the bottom guy, this guy, A total to other send A, 8. Now help me find the opposite. What is B given A? B given A? Where do they meet? We still meet at what? That's 2. But this time we're getting the total for
6. 2 over 6.
correct by 6 because the total for the bottom guy, which is 6, 0.33. All right. How about X given Y? Where do they meet?
Is it 8?
8.
Meet at 8.
But the total for what?
Total for Y 14.
14.
Correct. How about Y given X? 8 over what?
12.
6.
12, correct. So let's look at an example question. The following shows the number of cars of various types of local dealership. So we're given new, used, SUV, and sedan. What's the first thing to do whenever you're given a question like this? We get the totals. So let's get the column and the row totals. Am I first? Are we moving together? Have I lost anyone? It looks easy when somebody is solving, but now let's get to the actual gist of the question. So we have new, used, we're given sedan and SUV. And we're also given 24, 9, 15, 12. So what did we say is the first thing you do? What's the first thing we do?
Find the totals.
Find the total.
Yes. So let's find the totals. So totals. Let's start with the totals, side totals. 24 plus 15, what we get?
39.
39. 9 plus 12, what we get?
21.
21. Then 9 plus 24, what we get?
33.
23. Are you sure?
No, 33.
33.
33.
Then 15 plus 12.
27.
27.
7. And the total of totals here is what?
Skist.
60.
60. So this is our total sample space. All right. So can somebody help determine the probability that a randomly selected car is new? So what are they looking for?
We are looking for 39 over skist.
New. Okay. Good. So then you are looking at 39 over what? Over 60.
Skist.
And leave it in decimal. All right. Somebody else? Part B. And the probability that the randomly selected car is a sedan. What are they looking for?
33 over 60.
Probability of what? A sedan, right?
Yes.
Yes.
So that sedan is here 33 over what?
Skist.
Correct. About part 3, probability of a new and it's a sedan. There's a missing word here. New sedan. It's not missing per se, but it's correct. It's a new sedan. So probability of what? New and sedan. All right.
24.
And means what? Intersection, right?
Section.
So what would be the answer? 24. Yeah, right. 24 over what?
33.
Intersection.
39.
Let's go over 60, the grand total.
Okay.
How about lastly, they're looking for either SUV or used or SUV. What are they asking for? Ability, used or SUV. Or means what?
Union.
Union, correct. So how do we expand this? Probability of used plus probability of SUV minus what? Probability of used intersection what? SUV. All together.
Yes.
Such questions don't miss in the exam. I implore you to take keen interest in understanding these particular concepts that I've just unleashed. All right. So question number 3 of such a nature came in last year's paper. I've sent all the papers, the previous intake, so I need you to be reflecting on. So this was carrying about how many marks? 2, 4, 6. All right. The totals were given in here. So are there any questions on what has been discussed so far? Anyone behind? Are we getting better? So I sent you a tutorial sheet where I was getting the questions. I don't know whether you looked at this question with him today or any other day. So I'll give you this as homework. But I'll just modify some questions there. So please take time to follow the video, share it with you after the class. So lastly, I'll take you through conditional probability with the tree diagrams. Given the probability of A as 0.3, probability of B as 0.4, probability of A given B as 0.3. So we're being asked part A, find the probability of A intersection B. So to find the probability of A intersection B, you usually get the condition that has been given, A given B, you multiply it by the denominator times B. If you're given B given A, you'd have multiplied B given A times A because these two must be the same. So this is 0.3 times 0.4, I get 0.12. Part B, asking us to find A union B. Who can help? This one is easy. Formula for A union B, probability of A plus probability of B minus what? The intersection. So our A is 0.3, our B is 0.4, intersection is 0.12. So what do we get? 0.58. Then what is the complement of A? It's the opposite of A. It is simply 1 minus the probability of A itself. So the probability of A was 0.3, meaning the remainder, if A is 30%, the remainder is 70%. Without showing the calculation, what's the complement of B? It is 1 minus B itself, which is 0.6. Then if they ask you to find the reciprocal, instead of A given B, they ask you to find B given A. Using Bayes' theorem, I said, first take the bottom guy down here, then intersect the two letters A intersection B, usually start with the first letter, which comes first in the alphabet. So our A intersection B we already calculated here, 0.12. And our A has been given as 0.3. When you divide that, we get a 0.4. Then conditions, we have two conditions that you need to know. The conditions for mutual exclusive. If A intersection B is equal to 0, it means they are mutual exclusive. To be mutually exclusive means you have nothing in common. Events that cannot occur at the same time. So our A intersection B was 0.12. This is not the same as 0.0 exactly. So meaning at this point, we're going to conclude that A and B are what? Not mutually exclusive. When you multiply probability of A times probability of B, if they will give you an intersection, then you can know that these ones are independent. So our A was 0.3, our B was 0.4. So if we calculate this and we get the exact figure we got for the intersection, then we can conclude that these events are independent. So A was 0.3 and B is 0.4. So is this the same as the intersection? Yes. So we can say yes, they're what? Independent. Okay. So we'll end here for now.